Hello friends, very good afternoon. Myself Dr. M. H. Annaya, and in today's video we are going to study the development of the lateral surface of a square prism which has got base 30 mm and height equal to 60 mm, and this prism is resting on HP with two of its sides equally inclined to VP, that is like this. So friends, in the top you will be able to see a square with all the four shattered edges equally inclined to VP, and in the front view you will see these two rectangles. So let us place the object, the prism, on HP such that two of the base edges equally inclined to VP and obtain the top and front views. So friends, in the top view I am going to write a square of the given side. The given side is 30 mm. So I will just mark 30 mm here, and I'll mark these corners as A, B, C, D, A, B, C, and D. And center is O. So friends, here I am going to get the bottom face in the front view by drawing vertical line through all these. Remember, this gap and this will be same. This becomes A1 dash, this is B1 dash, D1 dash, last point is C1 dash. And we know the height of the solid, so to the given height we will obtain the front view. The front view is going to be a rectangle like this, and in the center you have got a line, that is one for this A. And here friends, we can mark this as A dash, B dash, D dash, this is C dash, this point is O1, O dash, this is O1 dash, the axis is perpendicular to HP. Now numbering should be done for this A1, B1, C1, D1, because for all these prisms and prisms, there should be double marking in the top view. This is O comma O1 center. The height of this is given to us already, that is 60 mm. So friends, you have got the front and top views of the square prism which is resting with two of its adjacent sides inclined at an angle of 45 degrees. These are 45, these also are 45 degrees to HP. Next comes marking of this development of this square prism, which is going to be a rectangle of height is equal to 60 mm and width is equal to 4 into 30. This is 30, 30 mm, 30 mm, 30 mm, and one more we have got, this is 30 mm. So there will be four rectangles when it is not cut by any section plane. This is how it will look. So you have marked all the four rectangles. So you have to just mark it as 30 mm, the width size of that. And there are four such rectangles. So I will mark here 4 into 30. So 4 is the number of sides and 30 is the width of each, that is 120. So we have marked the development when the solid is not cut by any section plane. Now friends, let us see how this object is being cut. It says it is cut by a section plane which is normal to HP and parallel to VP. That's nothing but a vertical section plane which is seen as a line in the top view and is at a distance of 20 mm from the axis. Friends, this is O1 is the axis. The section plane is seen as a line in the top view. So I am going to mark the section plane SS by a line parallel to XY. This is section plane SS and at a distance of 20 millimeter from here. So this 20 mm I will show here. So the section plane is cutting the solid at a distance of 20 millimeters from the axis OO. So friends, if you observe here, the section plane is cutting these edges here and also these bottom and top edges here. So now if you just transfer them to the front view, friends, this is these are the points where it is cutting at the top and bottom. Similarly, this is being cut here. So this is being cut here. So we can just show here. So there are 2 points in the top, 2 in the bottom. So there are totally 4 points where the prism is being cut. Now friends, in the question is asking, draw the development of the lateral surface of the larger part of the prism. So after this being cut friends, I will show the portion that is retained. This is the larger portion of the solid that is retained for obtaining the development. And the smaller part here, this part is thrown out. Friends, now you will have to obtain the development of it, and before that we have to observe in the section plane, that is this section plane while cutting the solid. After this is cutting the solid, we are going to throw away this part, this small part. That means the vertical edge, say it is the vertical edge that is being removed. So you are going to have a section plane like this part is going to be removed. That is BB, the vertical edge is removed by the section plane, and hence in that development you have to start only from BB. So this is B, C, D, A and again B. And similarly for the bottom face, this is B1, this is C1, D1, A1 and the last one is again B1. So the first line and the last line will have the same numbering. If it is AA, that will be AA. If it is BB, BB and so on. Friends, we all know that all the developments are drawn to the true size or actual size of the component, whatever it may be. Now here, if you see the section plane, it is cutting the edge AB at a distance of so much from B. So let us take the top face. On AB, nearer to B, I should take this dimension. On AB, nearer to B, maybe here. And similarly, on BC, at the same distance, we have to take on BC nearer to B. On BC nearer to B. That is to say, friends, whatever the dimension I have shown here, say I will mark it as M. This dimension and this dimension are the same. You can simply measure the distance using a scale and then transfer. So these are the 2 points where the edges BC and AB are cut at the top. Similarly friends, here for the bottom face also, it is cutting A1, B1 at this point nearer to B. A1, B1, AB, A1, B1 is here. Simply can transfer that line, that point to here. This is the point where this being cut, A1, B1. Similarly, B1, C1, the bottom face is cut here at the same distance. So same distance you can just transfer here and it is cutting here. Friends, these are the 4 points. Let me number them as 1, this as 2, this is 3 and this point is 4. These are the 4 points, 2 on the top face and 2 on the bottom face, where this section plane is cutting the solid. So let me join all these by dark lines. So I will mark this by a visible line, this by a visible line, the top face by a visible line, similarly the bottom face. So within this is the rectangle we are going to get, and all these lines that are retained. If you observe the top view, the edge CC, which is perpendicular to the board, is retained. This DD is retained, AA. So AA, BB and CC are retained. So let me mark them here. AA is retained, that is AA1, Then BB1 is retained, sorry, AA1, DD1 is retained, and CC1 is also retained. And what happens? This vertical edge BB is removed. So when BB is removed, you don't get it in the development, and you don't get these two connections also, connecting line. Likewise here you don't get BB and this connecting line on that. So friends, this rectangle 1, this is 2, 3 and 4 will give the complete development of that part P. I will call this part as P. P is the larger part. I will say here development of P. Development of P. P is the larger part of that. And friends, if you want, you can transfer these points also. 1 and 2 you can mark here. Come 1, 2, 3, 4 or here also you can just mark. Otherwise, we are interested only in the development. This figure or this rectangle will give you the complete development of the larger part and the lateral surface of the larger part. Friends, I hope the presentation was interesting and is useful to you. And if you think this is of some benefit to the students doing their BE program, please share the information with all your friends. Ask them to subscribe. Have a wonderful day. I thank you for watching my YouTube video.